All right, let's finish up all of these examples. Let's look at example 6. Now in the top, we've got a couple of factorings to do. First of all, always look for your greatest common factor. So notice they both have an A. So I know I'm going to pull out one A. I just pull out my lowest power, but they're also divisible by 3. So I can factor out a 3A from both of those terms. Then remember, I'm just trying to look to see what I need to multiply 3 with so that when I distribute it, I get 12A to the third. So 3 times 4 is 12. A times A squared is my A to the third. All right, here I'm trying to multiply 3A by something to get a negative 3A. So I'm just going to put a negative 1 right there. Okay, now anytime you see a square in your problem, kind of ask yourself, am I completely factored? Is this completely done? This is correct, but it's not finished. We can actually go one step farther. We could factor this nice, lovely difference of squares. Notice that 4a squared is a square, 1 is a square. People forget about that one, don't. So I can factor that, leave that 3a out to the front. But this was like our last example. It can factor as what we call conjugates. There's a plus and a minus. Take the square root of the first term. Square root of 4 is 2. Square root of a squared is a. Put that in your first term right here. And then square root of the last, that 1 goes right here. So this nice, lovely 12a to the third minus 3a can be written. I know it's a lot bigger. You're thinking, why are we trying to make something bigger? But we'll show you here in just a minute. Okay, look at your denominator. What is your greatest common factor down here in the denominator? Well, I see my a's right here. I've got 2 in both of them, so I'm going to factor out an a squared. However, I can also factor out a 6. They're also both divisible by 6. All right, so what do you multiply 6 with to get 12? Well, a 2. What do I multiply my a squared with to get a to the third? An a. All right, and then what do I multiply 6a squared with to get 6a squared? Just 1. And I can start canceling some things out right here. Okay, notice I've got a 2a plus 1 in the top, a 2a plus 1 in the bottom. Okay, so again, I always do my binomials first. I cancel those. And then I'm gonna rewrite it just to kind of help me see it a little bit better. I've got that 3a in the top. That's my monomial, my one term. And then I've also got a binomial of 2a minus 1. Okay, so those are both left in the top. The only thing left in the bottom is my monomial, just my one termer. That is a 6, a squared. Now, when we look at cleaning up our monomials, that's just our 3a and our 6a squared. We could say, well, 3 will divide into both of them. So we just look at our numbers first. 3 divides into 3 one time and into 6 2 times. And then you can use your exponent rules to simplify the a's. Okay, it's just 2 subtract 1. However, please make sure, since there were more a's on the bottom, one of the a's will cancel, but there's still that 1 left on the bottom. Okay, so it's going to be written like this. In fact, if you've only got a binomial left, you don't even need the parentheses. If you put it in there, that's fine. But I just have 1. This a canceled with one of my a's down here. Remember, this is just a times a, so it canceled with one of my a's down here. And then I'm just left with this 2 times a in the denominator. Do not cancel these. You cannot cancel binomials or 2-termers with 1-termers. Okay, so just leave it. That is your final answer. Do not cancel that out and say it's -1. That's not what our rules say that we can do. You can only cancel 2 terms with 2 terms. So notice we canceled our 2-termers out, but our 1-termers can simplify, but we now just have 2 terms over 1 term. That's your answer. All right, let's look at our next example right here. I always, I'll start with the easiest ones. I would probably start with the bottom, but let's look at this top first. I noticed right off the bat, these are all even numbers. That means I can simplify. I can divide it by at least 2, and when I check, 2 is the biggest number I can divide everything by. So 2 times 3n squared will give me the 6n squared. 2 times positive 8 or 4n will give me that 8n. And 2 times 1 will give me that 2 right there. All right, I can actually go one step farther. Now, this is everyone's favorite type of polynomial two-factor. Let's talk about this. That 2 stays out front, and we're going to turn our trinomial into two binomials. Now, this one is a guess and check. When you have a leading coefficient out the front, you've got to do a little bit of guessing and checking. It's not too bad, though, because on this one, there's only two numbers that multiply to 3. If we would have left it at 6, it could have been 1 and 6 or 2 and 3. But once we get it down to 3, the only numbers that multiply to 3 are 3 times 1. And remember, they've also got to multiply to that n squared, so we're going to add n's in with them. So 3n times 1n gives me that 3n squared. Okay, usually you have to guess a little bit, but this one is actually very nice to us because this one also only has one way that you can get 1. The only two numbers that multiply to 1 are 1 times 1. Okay, when we're checking them, we've kind of made it so our first terms multiply to this and our last terms multiply to this. So you just really need to double check that when you distribute your 3n to your last term, these outside terms and these inside terms, they've got to combine to this 4n. So this 3n times 1 is just 3n. When I add that to 1n, I do get 4n. So this was a good guess. Like I say, it wasn't really a guess. That was the only way I could have done it. But that trinomial turned into those two binomials. Okay, let's look at factoring in our denominator. Again, I see that there's a 2 in both terms. I'm going to factor that out first. 2 times n squared is 2n squared. And I'm going to need a -1 to turn that 2 into a -2. And do not forget, if you see a square, think you probably can keep going. Okay, so you've got this subtract right here. It's a difference of squares. This can factor into our conjugates. Got a plus and a minus here. Remember, just take the square root of the first, put it in the first term, square root of the last, put it in the last term. And I forgot to cross that out earlier. Now we've got some nice little stuff in the top and the bottom. Okay, some people like to write it all out. Maybe I should even do that on this one. So once I get it all factored, if you want to go ahead and just write it so you can see it a little bit better, since these are kind of far apart. I've got 2 in the top, a 3n plus 1, and a 1n plus 1. You don't really need that 1. In the denominator, I've got a 2 times n minus 1 times n plus 1. All right, when we go to simplify, again, I always do my binomials first. I see an n plus 1 in the top and the bottom. Those will divide off to 1. Look at your monomials. They're also the same. 2 divided by 2 is also 1. So those can just divide off. And I'm left with the 3n plus 1 is the only thing that's my binomial on the top, only thing on the top, over n minus 1 in the denominator. Remember, you cannot cancel those 1s. You can only cancel 2 terms with 2 terms, 1 term with 1 term. So don't cancel half of that. All right, let's do this last example here as well. I'm going to, let's see. I'm going to actually do something. I know this will turn into a negative. When I see my W after a number, it'll turn into a negative, but I'm going to have you guys rewrite this because I think it's easier. If you rewrite this just in the different order, we're going to put our W's first. So I've got a -5W plus 45. I'm just going to write it right like that. And I can factor out, I like my variable, especially if it's in the first place, I like it to be positive. So when I go to factor this one, I'm actually going to factor out that negative with the 5. So I'm going to factor out, I'm coming over here to do this. I'm going to factor out the -5, and then I'm left with a positive W, which I like. But in order for -5 to turn into a positive 45, I also need to have that be a -9. That way, -5 times -9 gives me that positive 45. Okay, so that's in the top. Notice in the bottom, I almost want to divide everything by 3, factor out a 3, but does 28 divide by 3? No, so this is going to be another one kind of like over here where we have to do some guessing and then checking our answers. Okay, so I know, again, my only 2 numbers that multiply to 3 are just 1 and 3. So I'm going to just throw those in. I've got a 1W and a 3W as my first terms. You can also look at the signs. Notice they multiply to a positive. However, they add to a negative. So the only way that you can multiply to a positive is if your signs are the same. If they're either both positive, you get a positive, or both negative. Since they want to add to a negative, you are going to make them both negative right there. All right, now here's where our guessing comes in. We've got a few numbers that multiply to 9. It could be 1 and 9, or it could be 3 and 3. So you just want to plug some of those in, guess them, and check them. So notice I'm going to do this wrong. I do know the right answer, but I want to show you that it's okay to do it wrong. I've kind of told the class, always check the ones that are closest together. Notice this term is huge, so you don't want to do that on this one, but let's just say that we wanted to guess 3 and 3. Notice when we go to check it, we've already made it so our first term, we don't have to check that our first terms are our last terms. We just have to check that when you do your outside terms here, the 1w times negative 3, that gives me a negative 3w. My inside terms, negative 3w times negative 3w gives me a negative 9w. When I combine those, when I add those together, that gives me a negative 12w, not my negative 28w. Okay, so we did it wrong. We're going to erase those really quick, and then, but I wanted to show you that that's kind of what you want to do. If you're new to this factoring, just kind of still guess. It doesn't work. Usually you try and switch your numbers. Like if it was 1 and 9, you could do 1 and 9 like that. With the 3 and 3, it doesn't matter when you switch the numbers, they're the same. All right, this 1 and 9, since I see this big number, I know I want my 3 to multiply with my 9 to get really close to this. So I'm going to put my 9 right there so that those two multiply together, and then my 1 over here. Now when I go to check this, I've got a negative 1w, and I've got a negative 27w, and those do add to my negative 28w. So I did guess the right ones there. All right, let's go ahead. We're going to write everything in the top down here. So I've got a negative 5 times w minus 9 all over. And then in the denominator here, I've got a w minus 9 times 3w minus 1. All right, now just go through and divide off what you can. Notice I have a w minus 9 in the top, w minus 9 in the bottom. And there's monomials up here, but nothing down here. So this is just my answer. I've got that negative 5 in the numerator over 3w minus 1 in the denominator. And we are done with these examples.